Good afternoon, class. This is Miss Richards, your teacher for this semester, and I just want to show you what a first video might look like. All of these definitions are found in your textbook in Chapter 1, Section 1. So if you don't really like the video and you like more visual, you can use the online text and you could take these same notes. First thing we're going to talk about is a point in geometry, and these are all these definitions are the essential building blocks of geometry, and you really have to understand what they are in order to succeed in the class. So a point is very simple. It's represented by a dot, but unlike physical dots, it has no size. A point is just representing something in space, and points, if you had to label them, are labeled by ordered pairs. 5, 7 on a coordinate grid. Otherwise, you can't really label a point. What you have to understand is that because they don't really exist, you can't really go out in space and look for a point. They don't have dimensions, so they're not really there. You use them to mark your own things. There's no other way to name a point except you can write A or B if we were labeling a diagram. The second thing is a line. And a line, it's represented with 2 arrows heads, but it extends infinitely without end. What you have to remember, through any 2 points, there's exactly 1 line. So you have to remember that 2 points are required to make a line. And that's why you only use 2 points to name a line. Even though there is infinite points on a line, you only use 2 of them. So for example, this line right here, it has A, B, and C on it, but it doesn't matter whether you say AB or you say BC, it's the same line. Anything in the line family, when we get to more stuff, you'll realize has 1 dimension. So there's only 1 single dimension in a line. And here are some ways that we could name this line. We could name it line AB, and you'll see the line symbol above it. It has arrowheads going in both directions because lines are infinite. You can name it BC. Now, you could also name it, if you say AB, you could say BA. If you say BC, you could say CB. And we could name the same line AC. You'll see in your textbook that they put this cursive letter sometimes. This is another way to label the line, but you can't just say line, you can't just use M. You can write it out formally and say line M, but you need the word line if you're going to use that method. The next shape we have is a plane. A plane is represented by a shape that looks like a floor or a wall. It's a flat surface, and it extends infinitely in all directions. So even though this looks like an index card on our page, you have to remember that planes are infinite. Therefore, a plane, since it's a flat surface, has 2 dimensions. So anything in the line family, lines, segments, or rays, have 1 dimension. A plane has 2 dimensions. A point has no dimension. And we're not going to talk about anything yet that has 3 dimensions. So please don't consider 3 dimensions an option. We have to be able to label a plane, and you'll see here that there's 3 dots, and then there's a big letter M. Well, just like the cursive letter M in the last thing, I can say that this is plane M, but you need the word plane. And if you don't have the word plane, you can't use the letter M. Since 3 points determine a plane, hence why a 3-legged stool never tips, or a tripod, why some people use tripods to take pictures, because 3 legs always make a plane. You only need 3 points to name a plane. You don't need any symbol when it comes to them. So as long as you just put 3 points together, A, C, B, you can name that CAB, or you can name it ABC. It does not matter the order, but any three letters go together, they make a plane. You can use four letters, but you don't really need to, because it's just oversighting. It's the same thing with the line. You would not call this line ABC. There's no reason to, because AB or AC is the same line. So that's exactly what it is with a plane. A segment, which is in our line family, so we already talked about this, if it's in the line family, that it has one dimension. What a segment is, instead of a line extending in infinite direction, it's a part of a line that starts at one point and ends at another. The points where they end are called endpoints. To name a segment, we use the endpoints. So we have two options, GH or HG, but you absolutely need the symbol above it when you're making a segment. So instead of having arrows on the ends like a line here, arrows on the end, segments do not have arrows because it ends. So that is a segment, GH or HG. Second thing in the line family, so if it's in the line family, we know it has one dimension. Segment, lines, or rays all have one dimension. And a ray is kind of like a combination of a line and a segment. So it's a part of a line that begins at one point, and that's what we call the end point, and extends infinitely in one direction. You must name a ray by using its endpoint. So if you look at this picture, can you tell me, do you think E or D is the endpoint? Hopefully you said E. So if E is the endpoint, you have to start the ray with E. So our only option is ED. I cannot call this ray DE because ray DE would start at D and go towards E. That would be the other ray. Since we need to distinguish a ray from a segment or a line, please note the symbol above a ray. It has basically an endpoint and infinite in one direction. Segment has just lines above it, and then a line has arrows on it. So just be careful. Another definition that chapter 1.1 talks about is opposite rays. So you'll see here that we have a line, but in this line we have rays. So opposite rays are two rays that lie on the same line. That's part of the definition. They have to be on the same line. I can't just take a ray and say, okay, well, this ray goes this way and this ray goes that way, so they're opposite rays. Well, it's not true because these two aren't touching and they're not part of the same line. So they have to be on the same line, they have to go in different directions, hence the word opposite, and they have to have a common endpoint, which is a common starting point. So out of this picture, I can't pick any other ray except B to start with because that's the only one that will go in opposite rays. BC goes to the right, BA goes to the left. So that is my opposite rays. Even if one went up, please note they have to go in complete opposite directions, hence why they have to be on the same line. So even if you had a ray going up this way, it wouldn't matter because B, whatever goes up here, is not opposite BC. So opposite rays, same line, different directions. We have two more definitions, and one definition is said to be collinear. And if you try to break down this word, co kind of meaning two, linear meaning line. So basically this is points that lie on the same line. Since it's collinear, and we already know that 2 points make a line, any 2 points are always collinear. It doesn't matter. So even though I look at this picture and I say to you, are B and D collinear? I know they don't look like they're on the same line, but I could easily, that's not the one I wanted. I could easily take a line and draw it between those two. So B and D are collinear. Co meaning two, linear, that is the definition. Any 2 points are collinear. But 3 points can be collinear if they are on the same line. So are A, B, and C on line AC? Our answer is yes. And then are A, B, C collinear? Yes. Are A, B, D collinear? No. A and B are, A and D are, but A, B, and D are not collinear. So you do have to understand what collinear means, and you have to understand what coplanar means. Now, understanding that co means two, but in a plane it's different because 2 points don't make a plane. In order to make a plane, we need 3 points. So any 3 points are always coplanar. If you look at these 3 points, I'm looking at number 3, I'm skipping ahead. Well, I'll give you the definition first. It's that points are said to be coplanar if a single plane contains them all. So it's basically if all the points lie in the same plane. If you look at this box, there's simply by eye 6 planes. The top of the box, the bottom of the box, the left, the right, the front, the back. So if you looked at the top of the box, hopefully you could be able to tell me that A, D, H, and G are all part of the same plane. So are A, H, D, G coplanar? Yes, they all are on the same plane. Are A, H, and G, which are A, H, G, which are all up here, but then B's down here, are they on the same plane? Well, 3 of the points are on the same plane, but B is not. And as long as there's one that does not lie in the same plane, it's not coplanar. If you come to number 3, A, H, and D, you don't even have to look at the picture. Any 3 points are always coplanar because they make the plane. So if A, H, and D, even though they're here, A, H, and D, and you don't have a point, you know that G is part of that point. So any 3 points are always coplanar. So I don't even need to look at the picture if I ask you a question. The same goes here. If I only ask you about 2 points, are B and D collinear? Always. So any 3 points coplanar? Yes. Do 4 points have to be coplanar? No. So that's where you need to make a deciding factor. And that's something you might want to write down because I've noted a couple times. 2 points, I'll move it down. 2 points are always collinear. 3 points are always coplanar. I'll move it down. All right. Write that down. I think from this you'll be able to pick out some things that we do tomorrow in class or today. Can't wait to get to know you guys better. Have a great day.